Hello everyone, welcome to this tutorial. My name is Emerson Ahrari. I'm a Google Earth Engine expert. In this tutorial, I'm going to show you how to calculate population growth rate in the Google Earth Engine Python API. So as you know, in the Python, we have more flexible facilities for the satellite data analysis. That's why I prefer to use Python in this tutorial. So in the first step, in the Colab environment, I'm gonna call necessary libraries that we need to have to deal with the Earth Engine tools and capabilities. So first of all, let's import Earth Engine related libraries such as EE and GEE map as GEE. Let's run a code, and here, as you can see, the code is running and server is connecting. If you had any problem regarding to the code and tutorial, just feel free to reach me out on my YouTube channel. So once the code is running, you can see it was successful, and then go to the next step in a new cell. So let's start with authentication. Before programming in the Python, we need to make a bridge between Colab and Google Earth Engine platform using authentication and initialization. Earth Engine initialize project. Here, you need to add the name of the cloud project that is connected to your Google Earth Engine account. In the right panel, you can see my code editor environment. That's here in the upper right. Go to the project info, and then you can find the cloud project name. For me is EE Emerson Ahrari. This is a unique cloud project for every user. You can copy and paste it into your code. That helps you to make an appropriate connection between Colab and Earth Engine capabilities. So let's run a cell, and then a new message popped up. Click on allow, and after a few moments you need to select your account, Gmail account, or the account that is connected to your Google Earth Engine. Let's continue and continue again. You can see it's under process, and now we connected to the Google Earth Engine, and easily you can use Earth Engine and Python capabilities same time in the Colab environment. So as you can see, a new code or a new cell created. First of all, we need to select the region of interest. To enter the region of interest, you must have the coordinates for your region. In the right panel, go to the code editor environment and find your region of interest easily. There are a lot of ways to find and define the region of interest in the Colab environment, but this is my way, and also I'm suggesting to use this because this is the simplest method I ever found. So, for example, in this tutorial, I'm gonna study on Tehran population, Iran's capital, and I'm gonna monitor the population changes since 1975 to 2030. So you can use this tutorial, or you can select your own region of interest. This tutorial can be used for all around the world, not limited to a location or actually a specific region of interest. Zoom in into your region of interest using the drawing rectangle or drawing tools available here. Select your region of interest. So here, let me to make it a little bigger to cover up the study area completely. So there it is. Now I need to get the coordinate of this region. So let's get a print from geometry. Geometry.coordinates. When you run a code, let me to make it a little bigger. That helps you to see the code easily. So under the list here, you can see we have one list with 5 elements. Let me to make it a little smaller because I'm gonna actually show everything clearly for you. In the right panel, we have 5 elements or 5 coordinates explaining the location of the geometry. So just copy and paste each element into Colab environment. The first element selected, now a new bracket created. So the first element paste like this, and when you want to go to the next line, it is better to add a backslash in the Python. That means the code is continuing. So go for the second element, copy and paste it again. Do the same for all elements. So that was the second one, and the third element, again selected and paste here. So you can see the fourth element selected and paste. So there it is. It's very simple and without any challenge. So, and paste it. The coordinate actually transferred, all the coordinates transferred from the code editor environment into Colab environment. Let's get a print from the coordinates. As you can see, we have a list including different elements or coordinates, but these are just simple coordinates and not explaining a region of interest. If you want to draw a polygon using existing coordinates, you must make a new variable. For example, the region of interest or ROI equals to earthengine.geometry.polygon. There it is, .polygon coordinates. So let's print the ROI, and after a few moments, result returning a polygon with 5 vertices, a list including 5 elements, same as what we had in the code editor environment. So now in the next step, I'm gonna visualize the region of interest in the Python environment. Let's make a new variable map from Google Earth Engine map, already called as GEE here. .map allows you to have access to a base map. For example, I'm gonna have a base map with a satellite background, and then map allows me to do the center object or run the center object function based on the region of interest. I'm gonna have focus on the region of interest to make sure the ROI created correctly, and I'm focusing on my own region of interest. So map.addLayer allow you to visualize the ROI. Let's leave the visualization parameters empty, and the layer name could be ROI. If you want to see the map, just write the map and run the cell. After a few moments, you will have focus on the selected region, same as what you did before in the code editor environment. Now, as you can see, the area selected successfully, and now I can actually continue programming in the Python step by step. So the region of interest created. In the next step, I'm gonna call population data, GHSL population data. It is one of the most valuable products produced and available in the Google Earth Engine platform. GHSL population. Just type it in the actually tabs available here for search. As you can see, global surface data is available since 1975. This is the full name of the product, and the description mentioned or provided enough information about the source of data and characteristic, and it's available since 1975 to 2030 with 5 years interval and 100-meter spatial resolution, with only one band that shows how many people living or estimated the number of people who are living in each pixel or covered in each pixel. So collection snippet allow us to copy and paste the its ID into a new code in the Python environment. So a new variable as population created, and let's get a print to see what it is included. Code is running. Earth engine.image collection GHS population. Now it's in progress, and sometimes you may face with a little bit delay, but it's okay and there is no problem. If you face with any challenge or problem in the programming, definitely here it returns some errors that allows you to actually address the problem and write it and run it again. So now I'm waiting until code is running. As you can see, it's still on the run. If you faced with any challenge in the programming, just the code link is available below this video on description box, and feel free to pick up from there and compare your code with mine. And if problem still exists, and then you can reach me out on my YouTube channel and put your comments there. So as you can see, without any specific reason, we faced with the actually run problem. Just do it again, and now you can see the problem solved and results returned immediately. Here we have 12 elements that listed population raster data since 1975 to 2030 with 5 years interval. That could be very valuable for urban development monitoring. And each image included one band that shows the number of people or population count. So in the next step, I'm gonna show you a visual perspective from this product and how you can interpret the raster, actually appearance or visual characteristic of this data. So let's make a stack layer from population. In the left panel, if you click on this icon, you can see the name of the variables, and if you actually stay for a bit here, you can see the data characteristic and the data what it is available in each data easily. So the population stack equals to get the population data that was an image collection with 12 elements. Here pop dot two bands, make a stack layer, and then you can clip it based on region of interest. Let's print the population stack, and after a few moments, instead of 12 elements, you will have one single image including 12 bands that shows the population since 1975 to 2030. So in the next step, we want to actually visualize the population stack through the map.add layer, this time for population stack, and leave the visualization parameters empty. The layer name is population stack. Run a code and back to the GUI interface. Now here we have an interface that shows the population stack. Go to the layer setting here and then click on grayscale style, select your target year, increase the contrast, and then click on apply to have a visual perspective from your region of interest. As you can see, this map shows the number of people living in each pixel. So through the tools available here, if you go to the toolbar, click on inspector button, then you can see the number of people actually detected for it is not detected, it is estimated for each pixel that's listed from 1975 to 2030. The brighter area, higher population, and the darker area, lower population. So let's go to the next step. Now I'm gonna calculate the whole number of the total number of people living in the selected area, or ROI. Now we need to make a new cell, define a new function, and then get the sum of the people living in this area. So a new function should be created. The function starts with the definition. We want to define a new function. This is population count. So it has a one input that is img. So let's get the input image and return the sum of the number of pixels, sum of the number of values covered by each pixel. So the sum or population sum equals to get the input image and through the reduce region you will be able to do a spatial aggregation based on sum operator. So couple of arguments are necessary here. First is the reducer. Reducer.sum allow us to calculate the sum of the pixel values for the selected region. The region defined through the ROI and a scale for analysis equals to 100 because the spatial resolution for this data is 100 meter. So when you want to get the value, it is necessary to add values and get the first item at the end, just like this. Finally, the function should return the sum of the population or total population with the corresponding date. The date should be calculated here from the input image. So from each image, that date extracts the date of that image and format converts it to normal style or normal actually writing style such as year, month, and day, just like that. The function finally returns a feature collection. Each output return as a feature. Let's leave the spatial characteristic as none because we want to have a data frame with just included the temporal variations of the population for the region of interest. So one of the information should be date. I'm gonna have a column as date and another column as population. Here is population sum. The function created. Now we need to actually apply the function on population data. So let's make a new variable, population value. New variable, population value equals to, so as you remember, we had a variable, it was pop or population, included 12 elements or population images with 5 years interval. So bring it here, pop, and apply a loop structure. We want to apply the function on each image available under pop variable. The function is population count. And finally, we want to see the population value. The output, as I mentioned, is a feature collection here, included 12 features with two properties. One of them is sum of the population, that here you can see the total population in this region in 1990 is more than 5 million people, and as you can see in the last year it actually reached to around 10 million people or 9 million people. So the estimated value depends on the extent of region of interest. Definitely if you select a bigger region you will have higher population values. Okay, so in the next step I'm gonna convert the feature collection into a data frame, an Excel file, because I'm gonna calculate the population growth rate and other parameters that could be interested for the urban studies or etc. So in the next step, we need to actually convert the feature style into a list style. So here I'm gonna make a feature list. Feature list equals to get the previous variable. The previous variable was a population value. Get the population value, insert it into a list structure based on population value feature collection size. Then .get info allows you to actually make the convert the feature style into a list style. So now easily you can see under properties as a superclass we have two subclasses here. One is date and another one is population. So now we want to have a single list showing only date and another list only shows the population. So it's very easy to do. Let's make a new variable as date equals to, so a bracket created, items inside properties and date, because the date was under properties. Here you can see the date is under properties. That's why the first bracket is properties and the second one is date. This is the way that allows us to reach to the date through the properties. For items in feature list, yes, there it is. Feature list, there it is. And let's run a code. Here you can see easily we have access to the list of the dates. In the next step, I'm gonna do the same, this time for the population values. So another variable as population sum equal, because we already had a pop value. This time I make pop sum or total pop. So again, from properties select the population. Yes, it is pop. The pop property under the properties for items in feature list. Pop sum returned actually a list of estimated population for the region of interest, and we need to round the estimated population actually, because that in that scenario makes sense when you because the population number expected to be integer format, and also the digit numbers actually is a little bit weird, and such kind of values returned because we have done a kind of raster analysis based on a region of interest, maybe part of pixels missed and part of pixels only selected. That's why we have some digits in this way. So in the next step, I'm gonna actually use some Python library packages to convert these two lists or bring these two lists into a data frame structure for the further analysis. When I say the Python is flexible, and this step actually shows how we are integrating Google Earth Engine capabilities and Python machine learning libraries. So in the next step, I'm gonna call the NumPy as NP and pandas, two useful libraries that allow us to do linear algebra, NumPy, and also the data frame analysis or pandas. So a new variable as data frame is created. From pandas, we're gonna call the data frame here a data frame with two columns. The first is the date equals to the date list, and another one will be the population value equals to total population already estimated from GHSL product. So let's print the data frame, and here you can see the data frame that is available. But the problem here is, before going through the next step, we need to convert the date information to a readable format for the Python and machine learning analysis. That's why we need to convert it to the convert the date to the date time format as it is suggested by AI assistant in the Colab. So here get the date column first, and then throw the to date time. Here you can convert it to the date time format. Finally, we need the date as an index. That's why the data frame will have a new index as a date. Now let's get a print and see the result. The index column is date, and now the date column is readable by Python. So the population also shows the number of people living, actually the total number of people estimated for each year separately. If you want to have it as an integer, it is very easy to round the values. For example, to round to 0 without actually any digit number. Now we have all the values rounded, and now you can easily interpret the range of the values from one year to another year. If the population values is not accurate, maybe it is because of the region of interest, because in Tehran we have a little bit bigger or more population, and also some underestimation in the results. That might be because we used a drawing polygon here. If you use the official borders, definitely you will have a better estimation for your own region of interest. So you can replace this tutorial with your own shape file and use it based on the official borders to get a better estimation for your region of interest. Okay, now we have a data frame that shows the date and population. Some of you may want to get export from this table in this step, or maybe you want to do further analysis. If you want to get export, it is too easy. Just here, as you can see, the df index.toCSV allows you to get export from population. Here we will have Tehran population with CSV format. Let's run a code. In the left panel, go to the files, and Tehran population is easy to use and available here. Now, as you can see, you can have a preview from the about the output that shows they consider each year's and total population. And now click on the download and have it as a CSV file. It will be open it up into the Excel format, and easily you can do this. So back to the code. Now in the next step, I'm gonna show you how to calculate the population change, the percent of population change from one year to another year, and also I'm gonna show you how to calculate the population growth rate. These two index could be very beneficial for the time series for the population studies, that gives you a better insight about population changes. So for example, we already have the df index. I'm gonna make a new column as, for example, this is the population change. But before to calculate the population change, I need to actually show you how it will be how we can calculate it. So for example, here I'm gonna show the population growth rate. The population growth rate equals to, so here we will have a logarithm of division between the current year population to over the previous year, and also then the result divided to the year interval. For example, if you want to do this for yearly analysis, the interval will be 1. Otherwise, you can actually increase the interval values based on number of the years you are working, or the year interval between each variable. So this is the population growth rate, and then another index is population change rate, population change rate equals to yesterday, it was 2 days ago, I published another tutorial about urban change index, about uh, built up change index that actually followed the same equations, same as the population change rate. Whenever you want to calculate the change rate or change percentage between two sequence variable, this is the equation you can use, no matter it is built up index or it is about the built up or it is about the population. So the current value divided to minus subtracted from the previous value, the result actually divided to the previous values, and whole of the equation convert multiplied to 100. That shows the different that shows the rate of changes from the rate of changes from 1 year compared to what the situation you had in the previous year. So, and these two equations could be beneficial for the urban studies, and now I'm gonna show you how to calculate them here. Let me to make another cell for the second equation. Now you can actually see these two equations much better and easier to understand. Okay, and first we need to consider which variables are necessary. Current values already provided by the DF index and the previous one. How we can calculate or how we can reach to the previous parameter. Actually, the previous parameter is like this. Let me to make a current one. The current one is a copy of data frame index dot copy, just like that. So, and about the previous one, another variable as previous is created. Let's make a shift in the values with 1 unit here. So the previous one, let's get a print, and now as you can see, all population values shifted down one row here, and now you can see the current and previous values created. In the next step, we need to actually apply this equation. So now we want to make a new column as a change equals to, because first I'm going to calculate the population growth change rate based on percentage to see how much population actually changed based on percentage compared to last 5 years. So here uh, make actually a single parenthesis. That whole of equation is supposed to multiply to 100, and let's make another parenthesis as a numerator in which the current image subtracted from the previous one, their variables already created. In the left panel you can see the previous one and also the current one already created. So, and then results divided to the previous values, and finally you can get a print from data frame index. So this is the previous one. Sorry. So let's run a code, and now you can see how much actually the population changed from 1 year from actually 1 year to another year with 5 years interval. As you can see, the current values actually subtracted from the previous one and divided to previous one. That shows how much population changes from 1 year to another year. 9%, 4%, 5%. This is the population. So as you can see here, the population change calculated. Sometimes over the 5 years, 15% population actually changed. So in the next step, I'm gonna show you how to actually calculate the population growth rate. So this is the next step, the population growth rate data frame index. Now in the data frame index, we will have another, we want to have a new column. The new column name should be here, for example. Okay, what was that? The population, the first one was change, and this one will be growth rate. Growth rate. So equals to, so from NumPy, you can call the log value as it is suggested by the AI assistant and get the current and previous one. Get the actually population growth rate uh, based on number of years interval that you have. For example, the number of years here as the data available for each 5 years. Now we can actually divide it to 5.0. And finally, the data frame growth index. But it is, let's actually pay attention that the current and previous value should included only population. So in the left panel here, you can see the current has only one column with 12 rows, and also this is the same also for the previous one. So let's run the df index, and now you can see the population growth rate that changes from 1 year to another year. If you make a plot from each variable, and then you can actually get insight about how the population value changes. For example, if I from df index, if you have only the population value and plot it, you can see, for example, a linear trend that shows population variation since 1975 to 2030 without any more information. But in the next step, if you plot the population change actually from 1 year to another year, or change percent here, sometimes you can see that the percentage of growth or change percentage gives you different information that shows since 1975 to 1995 the temperature growth rate was very low, and also it had a downward shift that gives you a better insight about how the population growth or population values changing from 1 year to another year. Sometimes we have higher population growth or higher values from 1 year to another year regarding to the growth and changes, but sometimes it is lower. That's help us to to make a better insight about the data variation, or about the data frame index growth rate. Here you can do the same. If you click on tab, you can have the rest of the code. Dot plot, run a code, and here you can see the almost the same trend, but with different range of values. These two index, their results are too close to each other. Just in this tutorial, I was going to show some useful indices to population monitoring using Python API programming in the Google Earth Engine platform. I hope you like this tutorial, and if you face with any issues in your code, just feel free to check it out, the existing code below the video on in description box, and you can also reach me out on YouTube channel and put your comments there. Thank you for your attention.